Hey, this is Ethan Gilchrist. I want to talk about the video game database app I made for my CSE 3-5 class project. So what was my project idea? I was trying to emulate what already exists. I like video games a lot. IMDb exists and lets me easily track my favorite films. IGDb also exists and provides an open and public API, so I could give a shot at kind of creating my own international game database, a wrapper at least. So really I'm trying to just emulate what already exists. Design is fun. That was kind of one of the angles I was taking at with this. Existing library apps already have great templates to look at, so I took a look at like applemusic.app here and kind of took inspiration from their design for laying out my library view in my app. SwiftUI makes UI quick, which is nice, and you can still interface with the same models that we're used to, which again, just connecting the dots, connecting the pieces, it tends to be easy. There's issues, but things can connect, and when they do connect, it tends to be easy to populate these lists with data. So here's my class diagram. It's big. There it is. Did you get it? Okay. So there's a lot of abstraction and separation in SwiftUI. So when we kind of look at the massive class diagram, which is more model view model than it is model view controller, there's just a lot to look at. So we can kind of boil it down to the key views. There's really only three things that we need to worry about. And those are, you can see the main views there, right? And I've highlighted the main views both in Xcode and on my app, screenshot from the app. And so you can see what these views are, right? You've got the app view, which is ultimately just a protocol implementing a tab view. And that tab view extends to the search view, which is a navigation view. It extends to the library view, which is a navigation view. It extends to backlog, which is a navigation view. So you've got all these navigation views, and they've got their own variables, right? So search is just simply, it's going to have the text that's being typed in the search field, and it's got the list of genres. My search view displays genres recommended to the user. And the backlog view is just going to fetch from the user's library and then filter the list to show the games that are in their backlog, the different backlog types that I allow. And likewise, libraries. Libraries, also pretty complex, but it's still, ultimately it's just calling the fetch request on the core data just to get the user's library, and that's really nothing too crazy. There's some other pieces of variables in here you might notice, things that are ultimately just for SwiftUI design, like columns, which allow me to lay out the library columns that you see with the square album-looking shapes for the games. And also, I'm even calling in there the color scheme so that I can tell if dark mode is on. And then you can also see in some of these I have functions, right? And a lot of things are abstracted away to their detail views. Each of these have detail views, and those detail views have components and whatnot. So again, it's easy as 1, 2, 3, right? We have the library, the backlog, and the search. There are three things. They implement detail views, they implement list views, but ultimately they're nothing too complex at the outset. As long as you abstract your views away, you keep, I like to think of it as punting down the more complex elements of your view to a smaller component. And to a smaller component, as you keep making smaller components, it's easier to understand your SwiftUI views. For the so here's my continued explanation of the class diagram. I've got here the main models we need to consider. So models get complex with their APIs. We really need to focus it down to the simplest objects. In my case, what are those? That's permanent, right? So the permanent being core data outside of the app, which is just going to be like your API calls, and then just miscellaneous stuff. And I've got a screenshot of what you can see, like my model folder there, right? And so here I've just highlighted the main models that I had, right? So like at the top we have library game. That's just what I call my core data model. And you can see, in the core data model, I'm saving, the time of addition. That's just a nice record to have. It allows you to sort easily. Backlog type, right? So there's fields that are like types, which I just do integers in order to convert them later. And I'm caching certain data in the core data game, right? So it's not the API game, but I'm caching data like the ID, to call later in API calls. I'm caching information so that I don't have to make as many API calls, right? I'm caching the name, I'm caching the game's photo, and then there's fields like rating that need to be saved so that the user can save a rating for the game. And then I made a simple set function to abstract away some of the actions of creating a library game. And then you've got the game itself, and the game is the API call, and it's big, right? It's got all the information I need to pull in about a game from the API. There's a lot. There's a little bit of repetition because some things I need to save multiple types of so that I can interface with both the API and the cached game and the library view and the search view and the genre view. All these different views I have to consider. So there's a lot of fields there, whether it's just the release date of the game or the company that made the game or where the game was made. Then we've got the IGDb connection, which is the API connector to the International Game Database, and there I've just got the simple functions that I set up like search. I kept it pretty basic, just searching their database, fetching a game, fetching a genre, or searching an image. And I have a protocol that makes it so you have to implement those things in that model. And then there's also the location fetcher, which is a simple map kit tool just for fetching location based on an address. So let's move on to the MVC diagram, which is really MVVM for SwiftUI. It's still a lot. Yeah, but it's nothing too crazy to worry about. The same views matter here, right? It's still ultimately the app view overall that's abstracting away to the 3 views. It's still abstracting the search view. It's still abstracting the library view. It's still abstracting out to the backlog view so your app has a tab view right at the bottom of the screen has 3 tabs. It abstracts to those 3 tabs. I also included here just some examples of detail views and how they interface with, for instance, game detail view interfaces the library view, search game detail view, which is a little tiny to see there, interfaces with search. And also, ultimately all these pieces tie together and they will automatically refresh based on table data and have even more components. Core data plus the API gets a little much, and that's kind of why the diagram gets so big. But ultimately the data transference isn't anything insane. Here are the main models. In this case, we're keeping the same models. We're keeping the models discrete. We're understanding the interactions. So we're keeping things basic, right? In this case, I'm just displaying the fact that there's the IGDb connection, right? The API that provides the data for the API games, which I just called games, and then there's the library games of the core data games, right? They both exist. They're separate. They're separate stored objects. I could have cached things a little better, but I'm still learning, right? But they're simple objects that are stored and accessed. And the IGDb games are proto games fetched from the protobuf library. Also, just a few other models, right? Every model has to be carefully designed. We should make sure each model is a focused task, right? And so here, that's what the remote image model and the location fetcher are simple models that just generate an image from a received URL, or the location fetcher, which simply takes in an address, or in this case, we're just passing like the word United States, and then it's generating a center coordinate for you. So what are the capabilities of the project? IGDB's API it's complex, it's really powerful, and it's free. That's great. It lets me do a lot of things that I wanted to try and do in my own video game database, and without having to get all the data together, I can just make my own wrapper. SwiftUI's lists, lazy grids, tab view, state management, all these complex concepts from UIKit are really just simple to do in SwiftUI, and that makes things convenient. And here you can see in the video the grid views being shown. There are multiple lists. These things are kind of a pain to do in UIKit with laying things out and making sure all of your implemented boilerplate methods are in there. But programmatic UI ultimately and programmatic layout's easy, it's fun to do, and yeah, it's just convenient ultimately for everyone. So I think you can kind of see here as I'm demonstrating, the GUI is it's flexible. You can see how animations flow in, how data flows in from the API. Components like the search bar being shown there aren't even in SwiftUI yet, but we just create our own search bar. And again, fetching the API data, here I'm just calling like a fetch of a search, the fetch search function just to search games, right? So what were the limitations of the project, right? There are issues to consider, right? IGDb limits you to 4 requests per second. Some people might think that's a lot, but you'll realize right away it's not. I had to, like some places I was just trying to make an API call on every game on screen. That immediately killed my app pretty much, which makes sense with that limit, right? And you're able to have up to 8 open requests, but that's only if some of your requests start taking a long time, right? So that becomes an issue, and that means you have to get rid of API calls. Building an app is ultimately scary. It's difficult to do. I kind of put this point here, right? Sharpening the axe, the idea that you need to be prepared and plan out and sharpen your axe in terms of preparing yourself to build a solid foundation for your app. It's not easy. It's not easy at all. And frankly, I feel like there are a lot of mistakes I made with the way I set up some of my models. And that's tough, but these are things you learn as you practice. So that kind of comes into what my ultimately what my lessons learned were, right? I think I just need to study more of everything, right? I need to do more SwiftUI. I need to do more error handling, especially because I kind of just hid the errors away best I could. I need to kind of learn more about asynchronous interactions. I think sometimes those are very confusing, and just punting them to the main queue, the main dispatch queue of the GCD and SwiftUI and Swift, in general on the phone is best and easy, but it's still confusing. And Swift is currently considering adding async and await as a keyword, which could be convenient for this. Is core data best? I think core data has scalability issues. Obviously, I'm not storing a lot of records here yet, but if a user adds like 20,000 games, not likely, but you never know. How does the app scale? And is iCloud the next step? Apple provides a simple tool just to kind of convert your core data libraries to iCloud, so that's something I'd want to explore. I think ultimately what I want to do next, and these are things I would have loved to implement if I had more time and set up a better foundation for myself, sharpen that X better, right, was I want to have like editable fields, right? So there's API data, but I want to be able to edit the API's data, and not edit IGDb itself, but allow the user to edit their version of the game to have different information than IGDb. Likewise, I think it'd be something I really like. I really like video game music, so it'd be fun to let the user link their Apple Music library to the app and then link songs from the game into the record for the game so that they can listen to their music in the app while reading about the game. And then I want to consider how I could bring my app to iPad and Mac. iPad's not terrible, but not terrible to port to, though there's a lot to consider. But porting to Mac is certainly a difficult task. Getting easier with the new M1 Macs, but that would certainly be fun to learn, but also difficult. What would be my suggestions for the future? I think SwiftUI ultimately is the future, kind of. Clearly it has limitations, issues. There are bugs in my app that are as a result of SwiftUI not being finished, right? It's very much a beta product. It's matured a lot since SwiftUI 2 came out in June, but even then, it's still got a long ways to go. I still think it should become a bigger focus in the class, though. Asynchronous interactions are tough. We covered them in class, but I think we could have spent even more time on them, honestly, and covering how to do proper error responses, maybe with an example from an existing API, even like IGDb. Group work, I think, group projects a lot of people think they're annoying. I think they could have merit, though, here. In my database class, CSE 412, I had a great time working with my group and building a project there, and I think that it lets you build a bigger project and possibly a group working together in this class. Maybe not for a full project, maybe just one assignment could have potential. Though Xcode is a difficult app to share, GitHub would best, you would need to convince your students to use a Git repository in that case. I think Swift Package Manager, something I kind of started screwing with here at the end of the class, has a lot of potential and should be shown more than I think CocoaPods, or should be introduced alongside CocoaPods, because Swift Package Manager is really lightweight. You just throw in a repository link from GitHub or another Git hosting website, and you've got your package imported into your app. It's really easy. And I think designing from scratch is something we should discuss more. It's difficult. I think, like I mentioned, my dumb sharpening the axe metaphor, it's really difficult, in my opinion, to understand what the best methods are for designing your app, from the model to the UI to everything, really. How are you going to set up things for the future so that it's not a headache and you don't have to continue redesigning your app? So I think it's something that would be worth discussing and exploring as how to help students design better apps for themselves and for others to use. So yeah, that's my full slideshow. Thanks for watching. I had a great time in this class, probably my favorite class at the school so far. I've learned a lot, and I'm looking forward to continuing my journey with Swift in the future, especially SwiftUI. Thanks.